The controlled experiment as part of the scientific method. So here I wanted to explore how the controlled experiment is a good way to employ the scientific method and to discover reliable truth that control for biases and other potential factors too. An experiment is a procedure for making reliable and valid claims, what we also call true claims or accurate claims and so on, about phenomena in the world, usually employed to understand general causal mechanisms. So this is not always the case, and it's not necessary, but it's often the pursuit of science, which we want to understand both causal mechanisms, so relationships of cause and effect, the impact, essentially the impact that one thing, event, or process has on another. But we also want to examine these general impacts. So not just, what made me drop my coffee on the floor this morning, but what generally makes me wake up in the morning and go to work. So just more general kind of repeated set of events or processes. Controlled experiments consist of comparison of at least two groups where one is modified slightly and the other is not, called the control. So we control for something, and we control for various factors to test a single main factor or variable of interest. And we'll talk more about this in detail here. Experiments need to be performed in a repeatable way and control for implicating factors and biases. And that's really their major goal. And that's essentially what they do, if employed correctly. So let's examine here with a non-technical information context, but a more lab health related context, but I think is good because we see it from different perspectives. So let's take this drug experiment example. Suppose you want to investigate if drug X can help lower blood cholesterol. Your company developed drug X. Now you need to test it to see if this actually helps lower blood cholesterol. So usually we're going to do a controlled experiment. Probably some of the best ones called, you may have heard about this nowadays, randomized controlled trial. So randomized controlled trial, and you see here we kind of have all these terms here. Randomized controlled trial is just another word for experiment. And what's going to happen is we have a treatment group and a control group. The treatment group receives the drug. The control group does not, but it needs to receive a placebo. Why? A placebo is necessary to control for the impact that believing in having a drug has on the treatment. This is a cognitive bias, namely the placebo effect. So if we don't give the control group anything, they're going to know they didn't receive the drug. So that itself will impact the effect of the drug, which is kind of an amazing thing if you think about it. But it's a real fact, it's a real bias, it's a real tendency. So it needs to be controlled for like other factors as well. And of course, the treatment group receives the drug. They don't know they received the drug. They think they may receive the placebo. So you mix and control those factors. That is this particular bias. Each group should have similar kinds of people randomly distributed. This is to control for confounding factors, that is, other things that can impact cholesterol level. So for example, if one group has many people that eat well and the other has many people that smoke a lot, it's not a fair comparison. It is difficult to determine if the drug impacts the cholesterol, or maybe it's actually the eating habit of the people in the treatment group. Maybe the treatment group has other people who eat well and the control group has other people that smoke a lot. So it's good to randomize, and so you can actually put similar kinds of people or a good distribution of different kinds of people in both groups. The implementation of experiments should be blind to those who will examine the results. In fact, we want them to be double blind. The people don't know, and the researchers don't know them as well. So just one person who is just in charge of, giving out the doses will know, but they're not the main researchers, and they're not the patients either. If a scientist knows who is receiving the drug, the natural attachment, this kind of cognitive biases that people have to the drug or result can impact the results. So also it's going to be necessary to have analytical approaches to measure the relevant factors and for comparing groups. So for example, how is blood cholesterol being measured? Is it total amount of LDL, or is it a ratio of LDL to HDL? Are you talking about total cholesterol? Does it include VLDL? Are you measured before eating or after eating? And this is what we also call outcome variable or response variable. So this is usually the one thing or factor that we want to examine to see if it's changing based on our treatment, drug X in this case. So the way we measure the outcome variable is important. And there are usually many different ways to measure. Also, how different should the results from the treatment group be compared to the control group to determine if the drug is effective? So if one is, for example, the drug group is at 10% higher than this one here, then is that enough? Does it have to be 20% more people got better with the drug compared to the placebo? So to do that, there are various statistical significance tests and other statistical tests to do these kinds of analyses. And one needs pretty good knowledge of them to really carry out these kinds of experiments with some degree of legitimacy and reliability. We have a pop quiz before we go. Who developed the modern scientific method? Perhaps many of you thought of people like Francis Bacon or those Europeans of the Renaissance, Isaac Newton, and so on. No, even 500 before Isaac Newton and Francis Bacon, Ibn al-Haytham was actually developing the scientific method. Was from Iraq, but I think he then moved to Egypt in 1965 to 1040. This is 500 years before the Renaissance. He actually had a book of optics, which I'm sure, and I think the history also indicates that all the Renaissance people, including like Isaac Newton, read and developed their theories from a lot of the Arab scholars. So just a nice piece of historical knowledge for us here. And next, we'll be moving on to A/B testing.